Good afternoon. Today we're going to talk about the geometrical transformation called reflections. Reflections are going to turn one image, one object into an exact image, but it will be a reflected image along what we call a mirror line or an axis. So we need in reflections a mirror line or axis of reflection, okay, along which from which that object is reflected. Okay, so again, we're going to have, like in every transformation, look, you can search for our videos on transformations, or if you're watching this through our YouTube channels or our online academy, you can check the chapter about transformations. We're going to have again two types of exercises, one where we're given the figure and the mirror line, and we want to transform that image through a reflection, and the other one where we're already given the transformation and we want to know, to describe it fully, to know which is the mirror line. Okay, so uh, let's start with this type of exercise. We're given a figure and we're given a mirror line, which is the straight line y equals x. Remember that the mirror line can be one of three. It can be either the x-axis. Remember that the x-axis has y equals 0 as the equation. It can be the y-axis, and this is going to be x equals 0. In the y-axis, all the points have 0 as an x, and it can be any straight line. And you know that straight lines follow this equation, y equals mx plus c, where m is the slope and c is the y-intercept. Okay, so now we're given a y equals x, so we're given a straight line. The first thing that we need to do is to draw that mirror line. Y equals x is, we can draw a few points, is the straight line where both y and x take the same value. So it's this straight line, and let's draw it. Okay, that was not very well done. Okay, that's it. Okay, so that's our mirror line, the mirror line that they have given us in the exercise. And we want to reflect this image through that mirror line. Okay, the best thing that we can do, and each thing that we can do, is just draw straight, perpendicular straight lines, perpendicular lines to the mirror line. So this has to be 90 degrees. Okay, and the reflected points have to be at the same on that line, at the same distance from the original point to the mirror line. For example, we can see here that diagonally there's one square from A to our mirror line, so there has to be another square in the reflected point. If we go to point, let's call this point B, and we draw a straight, perpendicular straight line, okay, so we can see that again it's one point across, so this is going to be our reflected B point. Okay, and if we do that with the third point here, sorry, we draw a straight line perpendicular to our mirror line, and our C point here has to be exactly at the same distance from the mirror line. So that's 2 points, two squares across, 2 squares across. So this is going to be our C point. Okay, so we can now draw our figure, our reflected figure, like this. Okay, so remember, if we're given the object and the mirror line, we draw the mirror line. then we can draw perpendicular lines to the mirror line that touch the this points in the figure, okay, and then they have to be at the same distance. Those points have to be at the same distance from the mirror line on both sides because it's a reflected image. Okay, remember that the image does not change in size, it just is reflected. Okay, so let's look at the other type of exercise where we are given a figure and its transformation. We can see it's a reflection here, okay, because if we try to do a rotation, you'll see that not all the angles are the same. Okay, so it's a reflection here, and we need to describe it fully. To describe it fully, we need again to find the mirror line, the axis of reflection. Okay, so to do that, again, what we're going to do is we're going to draw straight lines that join the equivalent points from our object to a reflected image. Okay, so we're going to do this. We don't need to do all of them. Okay, just a few of them. Okay, and then what we're going to do is our mirror line has to be at the same distance from the 2 points. So we could do a perpendicular bisector of these straight lines. If we did the perpendicular bisector of these straight lines and just joined those the perpendicular bisector of this line and this line at this line would be the same one. We can see very easily here that if the mirror line has to be at the same distance, 1, 2, 3, 4 squares across. So obviously it has to be this one. As I said, we can do the perpendicular bisector of the 3 straight lines, and that would give us our mirror line. But we can also calculate it this way: 1, 2, 3, 4, 5, 6. So that would be 1, 2, 3. This is 2, so that will be 1, 1, 2, 3. Okay, so that will be 1.5. I'm not going to do that one. Okay, so we can just join those. I will be here, here, here. So if we do this, okay, and we could put that over there. So that is going to be our mirror line. Okay, so what is the equation of this mirror line? We have to remember that all straight lines have equation y equals mx plus c. C is the y-intercept, so we can see very easily that c is 3. So we have y equals mx plus 3. And we only need to find the slope, okay? And we can use any point for that. So we can use, for example, here we found that we have -2, 1. So the y has to be 1. This has to be -2. So 1 equals -2m plus 3. 2m equals 3 minus 1. 2m equals 2. M equals 1. So we can see here that our equation is y equals x plus 3. That's our mirror line. Okay? So again, to find our mirror, if we have a reflection, we have to find the mirror line. To find the mirror line, we just connect the points from the object and the reflection. We can find the perpendicular bisector because they have to be at the same distance, or just calculate the middle point of each segment and just join them. And then we have to find the equation of that straight line. Okay, so that's the end of this type of transformation, the reflection. Make sure to check our other videos on the rest of the transformations.